In this video, I will give you an overview of the architecture upon which the Radicore framework was built. This framework is based on something which I had created earlier in two other languages. In my previous language, I had become familiar with the three-tier architecture, so I wanted this to be the starting point for my PHP version. The three-tier architecture is so called as the software is broken down into three separate layers or tiers, as shown in this diagram. There is the presentation layer or user interface, which handles all communication with the user. This deals with all HTML input and output. There is a business or domain layer, which handles all the business rules. This is the heart of the application, as it decides what action is to be taken based on the data which it is given. There is a data access layer which handles all communication with the database. This deals with the generation and execution of all SQL queries. In my previous language, I had also become familiar with XML and the ability to transform it into HTML using XSL transformations. So when I discovered how easy it was to use these in PHP, I decided to create all my web pages in this way. This meant that I effectively split my presentation layer into two separate components, which I was later informed by a colleague fit the description of the model view controller design pattern. Here you see that the user sends requests to a controller, the controller sends requests to the model, the view is updated using the data from the model, and the view sends the response back to the user. By combining these two architectures, I ended up with a hybrid architecture as shown in the next diagram. Here you can see the components of the three-tier architecture shown in blue and the components of the model view controller design pattern shown in yellow. Here is another diagram which shows the processing flow, which starts with an HTTP request, then flows through the three layers to the database, then back again through the view, which generates the HTTP response. This next diagram shows that there are actually a few more components as well as the model view controller and data access object. The HTTP request first goes to a small component script which identifies which combination of model view and controller are to be used to satisfy the request. The component controller or page controller, which is pre-built and comes supplied with the framework, calls a series of methods on the designated model with a separate model for each database table. All methods in the model are implementations of the template method pattern, which are inherited from a single abstract class. This means that any of my reusable page controllers can be used with any model. When a model needs to communicate with the database, there is standard code within the abstract class which instantiates the relevant DML or data access object, then instructs it to generate and execute the relevant SQL query. There is a separate DML class for each supported database: MySQL, PostgreSQL, Oracle, and SQL Server. When the model has finished its processing, the view will extract all of its data and copy it to an XML document. It will also copy in additional pieces of data from the framework, as well as the contents of the screen structure file, which identifies which piece of model data goes where on the screen. Finally, the view will load the specified XSL style sheet and use this to perform an XSL transformation to produce the HTML output, which is then returned to the user. The next diagram shows a few more details. It is part of the web page which explains the infrastructure of the Radicore framework, and each of the numbered items is a hyperlink which will take you to a more detailed explanation. When writing a database application, I follow those things which I have observed over many years of application development. The most important part of a database application is the database itself, so I design that first, following the rules of data normalization, and then I build my software to match the database structure. The software will not communicate with objects in the real world, only objects in a database. These objects are called tables, so I create a separate model class for each table. Regardless of the operations which can be performed on a real-world object, the only operations which can be performed on a database table are create, read, update, and delete. So I ensure that methods for these operations are available in each table or model class. The best way to share common code across multiple classes is to use inheritance. I put all shareable code in an abstract class so that it can be inherited by each concrete table subclass. Database applications do not work on one table column at a time. They work on sets of data, so I use a single array property to hold the contents of both the post array and the database result instead of using a separate class property for each table column. Every task or user transaction or use case always follows the same basic pattern. It performs one or more CRUD operations on one or more database tables. While standard code can handle the transportation of data between the presentation layer and the database, each object or model in the business layer may require additional logic to deal with other business rules. While every subsystem has its own set of tasks to perform operations on its own set of database tables, certain patterns can be observed over time. I categorize each task pattern as follows. Structure, how the HTML elements are arranged on the screen. Behavior, what CRUD operations are performed on those elements. Content, which models are used for each group of application elements. By designing my software to deal with those situations which I have observed, I have created a framework which provides those features which are common to any application, as well as making it easy to create new subsystems for different applications. Every component in every application is initially built using functions within my data dictionary. After table structures have been imported from the database schema, they can be exported to produce the class and structure files. Then individual user transactions can be built by linking any table to any one of my transaction patterns. By keeping the software structure synchronized with the database structure, I avoid the problem known as object relational impedance mismatch, which leads to that solution known as an object relational mapper or ORM. If a table structure changes, all I have to do is re-import that table into the data dictionary, then re-export it to recreate the table structure file. Because the CRUD methods within each table class are inherited from the same abstract class, this enables that code sharing technique called polymorphism. Each page controller calls these methods on whatever model object it has been given. If I have 40 controllers and 400 models, this provides 16,000 opportunities for polymorphism. To take advantage of polymorphism, I use dependency injection in my component scripts. By using a single array for all application data, I can pass that data from one object to another and one method to another without having to deconstruct it into its component parts. This promotes loose coupling as it provides the ability to add or remove columns from a table and its associated class file without the ripple effect of changing methods or method arguments when each column has its own getter and setter methods. When a task is generated from a transaction pattern, it creates a component script which links the following objects. Structure, which is provided by one of 12 XSL style sheets. Behavior, which is provided by one of 40+ page controllers. Content is provided by one of or more application models. In any PHP application which uses objects, there are basically two types of object. Entities which hold state and associated behavior. Examples of entities could be customer, product, and order. Services, which perform an operation. Each service encapsulates an activity but has no encapsulated state, that is, it is stateless. Examples of services could include a parser, an authenticator, and a validator. In the Radicore framework, there are four major objects: models, which are entities, views, which are services, controllers, which are services, and data access objects, which are services. All business logic is confined to entities or models. They are generated by the developer from the database structure which is imported into the data dictionary. All basic functionality is provided by template methods in the abstract class. Customizable hook methods can be added to any table subclass as and when necessary. There is no business logic in any service, so they can be used with any application. Because of this, they can be supplied in the framework as pre-written and shareable components. They do not need to be created or modified by the developer. Object-oriented programming is programming which is oriented around objects, thus taking advantage of encapsulation, inheritance, and polymorphism to increase code reuse and decrease code maintenance. The more reusable code you have, the less code you have to write and test. The less code you have to write to get the job done means that you can get the job done quicker and at a lower cost. A successful implementation of the features provided by an OO programming language should therefore contain a greater amount of reusable code than was possible with previous non-OO languages. Of the four major components, models, views, controllers, and data access objects, it is only the models which have to be created by the developer, and that is done by exporting information from the data dictionary. All other components are supplied within the framework and can be reused without any modification by any application that you choose to build. Although all models have to be created by the developer, they initially do not contain any methods apart from the constructor. All standard methods are inherited from the abstract class, which is provided in the framework, where they form the invariant methods of the template method pattern. This pattern allows custom business rules to be inserted into the relevant hook methods in each table subclass. Each of the three view objects, one each for HTML, CSV, and PDF output, can be used to display the output from any database table. The HTML view uses one of the 12 XSL style sheets which are supplied within the framework. These identify the structure of each web page. I have used these in my main ERP application, which contains over 20 subsystems, to build over 4,000 HTML pages. The controllers provide the behavior of each web page. They receive requests from the user before calling a series of predefined methods on whatever model they have been given. There are 40+ controllers available, one for each of the transaction patterns. The DAOs are responsible for the generation and execution of all SQL queries. Although all databases are supposed to implement the same SQL standard, they all have differences in their syntax, so each DAO has to handle these differences. Here is a count of the reusable components within the Radicore framework. There are 40+ reusable controllers. There are 3 reusable views. There are 12 reusable XSL style sheets. There are 4 reusable data access objects. There is one abstract class which can be inherited by every model. I have yet to see the same volume of reusable components in any other framework.